Okay, so this is a video about homework problem number 17.9. And the question is, of course you've got your book, but please look at it. The question is, evaluate the commutator. There's a couple other ways this question could be asked. You really should pause the video here. Put a star next to that. Pause the video and ask yourself, what other ways could this be asked? Okay? Unpause. Now what I'd like you to do is predict, right? You've already predicted. Let me tell you what I think it could be. Another one is, do these operators commute? Another way it could be asked is, can these measurements be taken simultaneously? Right? That's what this meaning is all about. Okay. So in order to do the problem, you need to know what this operator Px is. It's the momentum operator, and of course it's defined as that right there. It's on page 333. Please go look at that page and remind yourself what operators look like and how those operators are mapped over to what? Measurements or observables. Okay? Please review these words. They're all words that could get jumbled up in your head if you're not careful. Alright, so we just need to find out if those things commute. Alright, or rather, evaluate the commutator. So remember now that A hat, B hat, that's the commutator. It's the same thing as saying A hat, B hat on F minus B hat, A hat on F. That's what that is defined as, okay? And we've done this since chapter 13. A operating on the function first, and then B operating on the result of that. B operating on the function first, and then A operating on the result of that. So we're gonna write this out. This is the same thing as P hat plus P squared hat operating on P hat squared or Px squared hat whatever F, some arbitrary function, right? Minus P squared operating on Px plus Px squared of F, right? Okay. Now, this sum is another thing that we've done it a good bit, but it could be confusing to you. Don't forget, this is the same thing as saying this operating on that twice plus this operating on it once. Okay. So obviously there's a bunch here. I'm going to do what I always do. Divide this up into little pieces. 1, and going with our definition of what Px is, the momentum operator, we're going to say that this is minus I h bar ddx on minus I h bar ddx f. Okay? This, we don't know what the ddx of f is because it's a function of x, but we don't know what the function is. It's an arbitrary function. So all we can do is that's going to be in its final form right there. This is that times that. Now, this operating on that, that's just a constant with respect to x. So it really turns out to be minus I h bar squared, the second derivative of x with respect to f. Okay? So I squared is minus 1, so minus I squared is plus 1. And so this ends up being h bar squared. Okay? That's what 1 is. Now 2 is if we do that a second time. Right? You realize I'm making up this notation as I go, right? I'm just dividing it up into pieces that I feel like I'm not going to lose my way. So the second derivative of that, then, it's going to end up being minus I h bar ddx minus I h bar ddx operating on this guy here because that's what's inside there, right? So this is h bar squared ddx. Okay? So again, these are just constants. So I can see I can fold these three guys into d4, dx4. These two are going to get squared again, so it's going to be h bar squared, just like it was up here, right? These two are going to get squared again. So it's going to be h bar to the 4th d4 dx4 f. Okay? Now I see that what I'm going to do is take this guy and operate on that, because that's the sum of it. Okay? And so I'm going to say 3 is this here. Okay? 3, and that's minus I h bar d dx. And what is number 1? The result of 1 is that, h bar squared, so it's h bar squared, second derivative of f with respect to x. So this is going to end up being minus I h bar cubed, third derivative of f with respect to x. Okay, that's what number 3 is. And so it looks like this first term is going to be 3 plus 2. Do you see that? If you don't see that, please ask me. This is something we've done many times, and I don't want to reteach that in this video, but we don't mind. Certainly don't mind talking about it again. So this plus right here means that we're operating with. I said I wasn't going to reteach it. I can't resist. This plus means that we're going to take that operator and operate on this guy, and that operator and operate on this guy, and add them together. Okay, so probably should put parentheses around that, right? That's going to be confusing, but that's what that means. All right. So it looks like it's 2 plus 3. So this first operator then is h bar to the 4th d dx4 of f minus I h bar cubed d dx cubed f. Okay? That's the first term. I'm going back up here. That's that term right there. Okay, I just mapped everything out and then calculated it all out, and I've got that. Now let's do this one over here. This is going to be 1. That looks just like the one I did over here. So I'm going to say 1. I've already calculated 1. It's h bar d dx2 f. Okay. And 2 is going to be that operating on that. Okay. So that's going to be minus I h bar df dx. Not much else to say about that, right? That's 2. Okay. So this term here, 3, is going to be the sum of those two. So that looks like 3 is the sum of these two. So it's going to be h bar, second derivative with respect to x, minus I h bar. Or that must be that's h bar squared. Oops, almost lost that. Oof. H bar squared minus I h bar df dx. Okay, that's what 3 is. Now it looks like 4 is going to be this operating on that. Okay? 4, and this is a longer one, so I'm going to write it out. Minus I h bar ddx minus I h bar ddx. That's this guy squared, right? Times everything I got from 3. Or not times, but operating on everything I got from 3. So 3 is here. H bar squared ddx squared f minus I h bar df dx. Oof, okay. So this operating on all that, these are constants, no big deal. We'll bring those out if as necessary. But this operating on that is going to give me the third derivative and the second derivative respectively. Minus I h bar ddx. Okay, so that's going to be minus I h bar cubed d3 dx3 of f. And that, I've done this now a couple times. I did this over here, right? Minus I h bar squared. It's going to give me plus h bar squared d2 dx2 of f. Okay. Now this operates on all that. This is going to end up being, I'm doing this again, minus I times minus I is plus 1. So that's going to be h bar 4, right? H bar 4 d4 dx4 of f. That's the first term. In the second term, it looks like it's going to be minus I h bar cubed d3 dx3 of f. Okay, that's my whole thing now. Okay, so the commutator is this minus this. Okay, now let's look at it. This is h bar. These two terms cancel, right? Because they're both positive, and it's the difference between the two. Those two cancel, and these two cancel. Boom, boom, equals 0, and boom, boom, equals 0. Okay, so the commutator of px plus px equals 0. Okay, hope that's helpful. Commutators. That's a 0, right? Commutators. All right, that's routine. If not, it's certainly complicated, but if you get the definitions, it's going to be routine. Best wishes.